let's discuss dark matter once again, mostly because in the last few years it's become even more mysterious and more misunderstood, and mostly because of various discoveries made by telescopes like the James Webb that discovered things that just don't really make sense. But in this video, we're also going to be discussing one of the recent papers that actually tries to use dark matter to potentially explain some of the anomalies in the center of the galaxy, while also proposing a kind of a new type of a star. Not really a dark matter star, but not really a typical star either. Basically something in between. And so hello info person, this is Anton, and today we're going to discuss another intriguing proposition about dark matter, and basically discuss some of these new mysteries. But I guess first, a really important side note. As you might have learned from one of the previous videos right there, today it's basically kind of confirmed that dark matter would be very difficult to explain if this wasn't some kind of a physical particle. It's extremely unlikely to be a problem with the gravitational formula as proposed by various models like MOND, and the observations from various telescopes do actually suggest a particle-like nature. It's just nobody has any idea what sort of a particle, how big, how massive, what exactly it's made out of, or more importantly, why we can't seem to find it. Because that's really the biggest problem with modern research on dark matter. Despite so many propositions out there, so far, no actual discoveries. But the observations from various telescopes continuously confirm its existence. For example, one of the most recent discoveries coming from the James Webb is in regards to a typical Einstein ring, although technically it's this one, known as JWST ER1G. And what's unusual about this is that it's super compact, or basically it's just really tiny and perfectly circular, suggesting a tremendous amount of mass, making this a bit of an anomaly. It seems to have at least 6 times more mass than what's expected from similar objects, with one of the recent studies potentially explaining this as maybe a slightly different type of dark matter referred to as self-interacting dark matter. Or basically in this case, it implies that dark matter sometimes can produce enormously massive formations. And surprisingly, something extremely similar has been recently discovered by observing the famous El Gordo cluster, the most massive galactic cluster we've discovered so far, that basically serves as a proof of the existence of dark matter, but also the weirdness of dark matter. Once again, it's just a little bit too massive to exist so extremely early, suggesting some kind of a self-interacting dark matter or some other dark matter anomaly. Here the galaxies move a little bit too fast, so technically this cluster should have been already dissipated a long time ago. But here the dark matter is able to hold it together, implying extremely powerful effects. So in essence, there's a lot of stuff we still really don't understand. But the evidence here is pretty clear. Dark matter is definitely real, but it's also maybe a little bit strange, or at least stranger than we initially thought. But much more importantly is of course the evidence coming from the Milky Way galaxy. For example, as you might have recently discovered from one of the videos right there, one of the oldest mysteries of dark matter, the mystery of missing dwarf galaxies, has now been officially solved, while also creating a new mystery. There are potentially too many dwarf galaxies around the Milky Way, implying the formation of a lot of different tiny halos around the Milky Way galaxy, way more than expected. But if that's the case, we should actually see a lot of signs of these halos, or these tiny dark matter chunks, as they interact with various structures around the Milky Way. For example, one prediction suggests that various streams we've discovered in the last few decades should basically have a lot of signs of these halos potentially shooting through or interacting with these streams, most likely disrupting them. And even though so many have been discovered in the last few years, surprisingly, only one such stream has been officially confirmed to have signs of this unusual interaction with dark matter halos. We've discussed this a few years back, but this is essentially a stream known as GD1. And here, by analyzing data from the Gaia telescope, researchers from the Harvard-Smithsonian Center discovered unusual gaps inside the stream, suggesting that it was basically hit by multiple halos several times. Or essentially, it's as if invisible cannonballs made out of dark matter shot through this stream, leaving unusual marks behind. But unfortunately, that's the only evidence we have. Even though scientists expect a lot more of these, so far, nothing. Once again highlighting that even though there are signs of dark matter everywhere, it's maybe not exactly what we think it is. As a matter of fact, a lot of computer simulations trying to recreate galaxies using dark matter principles are still not able to recreate perfect galaxies. And that basically suggests that we just don't have a really good model to explain these dark matter particles. But some models so far have been leaning towards some kind of a self-interacting dark matter that can maybe even form dark matter atoms. Or at least dark matter that's able to form larger structures, such as stars. In this case, this is a concept known as the dark star. One of the videos in the description talks about this a little bit more. And if so, this type of dark matter was probably providing a huge amount of energy in the early universe. But it can also provide a lot of energy in a lot of locations with very high density of various dark matter particles, such as, for example, in centers of various galaxies extremely close to the central black hole. And so one of the recent studies explored this a little bit more, proposing that very close to the central black hole, possibly within about 1/3 of a light year, the overall concentration of dark matter becomes so high that it can easily make its way into various objects, such as stars. And specifically, it then starts to produce all sorts of interactions inside these stars, annihilating and creating energy. And in some extreme cases, so much of the stuff accumulates inside stars that they can actually start to appear a little bit different from what they should appear, and potentially even become literally immortal. Because here, all of the energy is now produced by dark matter annihilation and not hydrogen fusion. And so basically they propose a kind of a hybrid star, a star that used to be a regular star, containing a lot of hydrogen, but then consumed so much dark matter that it's now dark matter annihilation that's basically preventing the star from collapsing while also producing a lot of energy. Which would also suggest a new branch on the famous HR diagram, which represents the plot between a temperature of a star and its luminosity. But why exactly would scientists propose this, and is there really any evidence? Well, one of the reasons is because of various anomalies extremely close to the central black hole. For example, based on studies of various stars here, which are now referred to as S-stars, the ones that move at thousands of kilometers per second around the black hole, the researchers discovered that a lot of these stars are really massive and also extremely young, which by itself doesn't actually make sense. It suggests that the stars were either formed here or somehow managed to acquire a lot of mass while also becoming young in the process. Now, one of the recent videos you can find in the description explains this through the process of collisions, but this study proposes something a little bit different. Here they basically suggest that one of the reasons these stars appear so young is because of that dark matter. Or in essence, as these stars come closer and closer to that region with a lot of dark matter in it, they begin to acquire a lot of dark matter particles, which then starts to produce more and more dark matter energy, which essentially transforms these stars from possibly old-looking into baby stars, because suddenly they acquire so much new energy, and essentially become much brighter. And so for many of these stars, a lot of hydrogen in their core starts to fuse much slower, dramatically slowing down their evolution and potentially stopping it completely, literally implying that some of these stars remain completely unchanged for billions of years. And though some of the stars in the slightly lower density region would still burn a little bit of hydrogen, appearing just a little bit different, the stars in the high density region would most likely form an entirely new branch inside the HR diagram. Basically these unusual immortal stars. And the thing is, their simulations even explain another anomaly around this region as well. A while back, scientists discovered the existence of these somewhat unusual objects we now refer to as G-objects. Very bizarre star-like formations that seem to increase in size as they approach the black hole, just to change into star-like shapes once again once they move farther away. There's a video in the description that talks about this more, but in essence this is still one of the bigger mysteries. What exactly are these, and how exactly do they survive every passage close to the black hole? And so in the simulations from the study, scientists discovered that for much smaller stars, they actually do become very poofy and even become stretched, losing outer layers, on the close approach to the central black hole, but do reform once they move away. And so in some sense, this unusual dark matter proposition explains G-objects as well. But naturally, this is just one of many explanations for what's actually happening here. A lot of this is still pure speculation, and we're not going to know much more about this region until better telescopes and until further investigations, especially in a lot of different frequencies. And so whether this is dark matter or some unusual stars that we don't understand, we're actually not going to know much more for at least a few more years. Some of the newer telescopes, such as the Grace Roman telescope, might be able to help us understand what's happening here, but until those telescopes become operational, we're not going to know much more. And so until those future discoveries, check out some of the additional videos in the description below. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. This one also has a black hole on it. Anyway, stay wonderful, I'll see you tomorrow, and as always, bye bye.